Everybody that hasn't taken the test, Josh, you took the test yesterday? Okay, you need to put all your stuff up front, and you are going to take it now. You can watch the video and take notes at home. We're going to take the test in class today, right now, because what we're covering today, your phone, everything, backpack, everything up front, grab a calculator. If you have your own reference sheet, go and get it out. I'll give you an extra credit point for that and give you a copy of my reference sheet. All right, I think I'm recording. Yes. Did you guys see me drag the perimeter? Yes? Okay, then I'm recording. All right. Today we're talking about perimeter, circumference, and area. And we're going to be talking about area of other figures for this unit. These are just the ones technically already supposed to know, like we review certain algebra content. So this is some content that part of other courses that you've taken and want to make sure you have a good grasp of it. My board was not working yesterday. Hopefully it's going to work today. That's not looking super promising. You guys concentrate, Kyle. On your test, right? Good. So, perimeter. You know what perimeter means? What's perimeter? Perimeter is a distance around something. You might think it's a distance around a straight-sided figure. So, the perimeter of this room would be the length of all the walls added up. It would be the distance from this corner of the room. If we walked all the way around it, all four corners, right? So the distance around is the perimeter. Go ahead and take your earbuds out. That's the perimeter, the distance around it. How do we find the perimeter of a figure? We find the length of the sides and then add them up. If it's like a rectangle, there's two of the same size, two pairs of same length sides. They can use a formula for that, and we will. Perimeter. My board evidently is not going to work, so I guess I'm going to use the mouse. The distance around a geometric figure. Answers given in regular units like feet, inches, miles, and yards. And now this is a straight-sided figure, not a circle. So the perimeter of a circle is actually the circumference. So they're the same thing, but you can't measure the distance around a circle the same way you can measure the distance around a straight-sided figure. Alright, make sure your calculator is in DEG. Alright, any questions on perimeter? Alright, area. Area is how much space something takes up or how much space something covers. If you want to paint this room, you want to paint the walls of this room, you need to know the total area you're going to paint. Sorry? Yes. So how much area do you need to cover with paint? You want to find the square footage or the square unit of measure that you're going to use. So the area is the number of square units it takes to cover a geometric figure. Answers are given in square units like feet squared, inches squared, miles squared, and yards squared. Why won't my board work? So the next little things are the formulas for finding area or perimeter of a square. If you guys caught up with me, the one thing. So the formula for perimeter and area of a square, the perimeter of a square, a big P stands for perimeter, is 4 times the length of one side. So where S stands for the length of a side. So if you're finding the perimeter of a straight-sided figure, you're adding P equals 4 times S. So the perimeter of a square is found by multiplying the side length by 4. The perimeter of a rectangle, we could add all 4 sides, length plus width plus length plus width. But in a rectangle, the length is the same side, the width is the same, or the width is the same length, and the length is the same length. So we can make a shortcut and use the formula 2 times the length plus 2 times the width, right? How do you think we find the perimeter of a triangle? Anybody? What do you think? That's the area. The length of the perimeter of the triangle, you just add the sides of the triangle. And the sides of the triangle aren't always the same. So it's not 3, there's 3 sides to a triangle, right? 3 straight sides. You just add them all up. You can't say 3 times the side length because the side lengths aren't always the same. So I don't even know what I have there, honestly, for the perimeter of the triangle. Okay, so we have A plus B plus C because the side lengths aren't always the same. So you can't use S for side length here. Because remember we talked about the other day, give us the same variable on a figure, like a diagram, and that variable always has the same value. So if I put S on a triangle for one side, and I put S on a triangle for another side, that means both sides have to have the same length. So that's why we use A plus B plus C. They can have the same length. We learned about equilateral triangles, right? All the sides are the same, but not all triangles are equilateral triangles. So now the perimeter of a circle. There is no perimeter of a circle, but what we call it is the circumference. Yes, Tyler? All right, so to find the perimeter of a circle, it's not the perimeter, but it is the same basic concept. It's called the circumference, and it's 2 times pi times the radius of a circle. You've forgotten what the radius is. The radius is the radius is the distance from the center point of the circle to any point on the border of the circle or the edge of the circle. So it's 2 pi r, or the diameter times pi, right? Pi d. So there's 2 different formulas, but really they're the same thing because the radius is half the distance across the circle. The diameter is 2 times the radius. So while circle does not have a perimeter, it has a parallel concept, which is the distance from one point in the circle all the way around to the other point. That's kind of the perimeter. Does that make sense to you, and the area, Sydney, did you take your test yesterday? Okay, we'll put all your stuff back up front. You're taking your test today. Now we're going to talk about the formulas for the area. So if I want to know the area of a square, the area is the side length times itself, or we could say side squared. The area of a rectangle is the length times its width. That's how we know how much space that rectangle takes up. If we wanted to tile this floor, we need to know the area of this floor. This floor looks a bit like a rectangle, but it's probably, it looks a bit like a square, but it's probably more of a rectangle. We need to take the length times the width, and we know how many square feet of tile we needed to buy. A triangle, so the square and the rectangle, remember a square is a rectangle, right? It's just a special one because the side lengths are all the same. The triangle and the circle have completely different formulas. The triangle formula is 1/2 the base times the height of the triangle. I typically write that as the base times the height divided by 2. This is Imran. To you. Sure. Sydney, come get your stuff. Hector, take your things and go see Coach McGriff and attend it. Is your phone and everything put up there? Everything's got to go up here. Your phone? Thank you. All your things, buddy. Hector, take all your things. All right, and so V and H stands for the base and the height of a triangle. On the circle is area equals pi times the radius squared. So the only thing that we're going to use pi for is a circle. Kids are going to do it. Someone in here is going to do it. You're trying to find the area of a straight-sided figure by using pi. We don't use pi to find the area of the perimeter of any of the other shapes except for a circle. Yep, that's it. Or a semicircle, which is half a circle, right? So you got to be focused on your test, buddy. All right. So here we're going to say that the circumference is the distance around the circle. Gosh, dog it. My board just will not work. And the diameter is 2 times the radius. And the radius is 1/2. Maybe I can type it. Oh, gosh. Okay. 2 times the radius. And the radius is 1/2 of the diameter, and I'm just going to use that because I know I won't be able to insert equation when this board is not working. Okay? So the radius, remember, so this little dot here, that's the center point of the circle. The radius is from this point to the edge of the circle, right? The diameter is the complete length across the the circle through the center point. So the diameter is the distance from this point through the center point to the other side. The radius is half that distance. It's from the center to the outside of the circle. Does that make sense? So the base and the height of a triangle. So this is not a right triangle. It's showing this. This is the altitude here, right, where we're drawing this perpendicular line from one angle of this triangle to the opposite side perpendicularly. That is the height of the triangle. The base of a triangle is always the side that perpendicular line meets, right? So you can have different heights to the same triangle. I could draw the height from this triangle from this angle and make a perpendicular line to this side, and then the height might not be the same thing. However, Daniel, baby, the area is always the same. If the height is different, also the base is going to be different, and those differences will still produce the same area if you use them, right? But we use the height that they give us, and we have to know that the base, the side of the triangle that we use as the base, has to be the side that's perpendicular to the height. Any questions on that? And I think the squares and the rectangles are pretty self-explanatory. Okay. So we're going to find the perimeter and area of each figure. Normally I might try to work it out. I think that I've got it typed out here. So the formula for the perimeter is 4 times the length of one side, right? So it tells us here that this is a square by marking all 4 sides congruent and giving us the length of one side. If this side is 8 millimeters, all 4 sides are marked congruent. Now we know that that is the length of all the sides. So the perimeter is 4 times 8. And that would be 32 meters. It's important that you put your unit of measure on here. I've not taken off for you not putting units of measure on really up to now, but starting this unit we will, because perimeter and area would have different units of measures, either meters versus meters squared, and I need you to know the difference. All right, so you won't get full credit if you do not put the unit of measure if the unit of measure is given. All right, so to find the area, we're going to use that formula, area equals the side times squared. Well, the side is 8. 8 squared, we can use that x squared button on our calculator. You follow along, Jania? And the area is 64 meters squared. We're going to pick up the pace a little bit here. All done? Okay. The perimeter of a rectangle. So this is the one, and we know this is a rectangle. The congruent marks remind us that this side is congruent to this side is congruent to this side. So if they only give you this side length and this side length, you still have to know that you have to add all 4 sides. One of the most common mistakes is kids will add these 2 sides and tell me those are the perimeter, that's the perimeter of this rectangle, but it is not. All 4 sides have to be added. So 2 times the length plus 2 times the width, we use that formula we just wrote down the other slide, gives us a perimeter for this rectangle of 21 4/100 feet. To find the area of that same figure, if we wanted to carpet it, if we wanted to put tile down, if it was our backyard, we wanted to put new sod down, we have to find the area. Right? If we want to put up a fence in our yard, we need the perimeter. Right? It's not going to cover our whole yard. It's just going to need to be the length around where we need to put the fence. Usually one side of your house provides one side of that perimeter, but it just depends. Right? So perimeter is distance around, but area is going to be the length times the width, not the length plus the width, the length times the width, and that would be 24 feet squared. We are starting a new unit. We did take our test yesterday. I'm going to try to grade those the rest of the day today. This is a whole new unit. Make sure that you're keeping up. Let's start out strong. Don't get behind on this unit. All right, everybody caught up with me? All right, so we're finding the circumference and area of each circle in terms of pi. So this is kind of like when we wanted to find the exact answer if we had a radical or a square root symbol, right? Pi is an irrational number, and that means that what? Does anybody remember what irrational means? What do we know about pi? Never ends and never repeats, right? The only way to give an exact answer for a computation that you're using pi for is to leave pi in your answer. Now, we do substitute or approximate pi with 3.14 very often. Sometimes, to be a little bit more exact, forget the fraction, I'm having a senior moment. But there's they may tell you to use 3.14 for it. They may give you another fraction to approximate it with. But if they don't give you one, you can use the pi button on your calculator, but if it says exact answers or in terms of pi, that means you have to leave the pi in your answer. So if we're finding the area of this circle, first off, the circumference of this circle. Remember, there are 2 formulas for the circumference of the circle. So circle is 2 times pi times the radius, or pi times the diameter. Now let's look here real quick. Now, I can't highlight anything because this darn board is. You'll see 2 times the radius. That's the same as the diameter. Oh, here, this is supposed to have an R down here. If you didn't put the R down here, the diameter is not always 2. It's 2R. 2 times the radius. So 2 times the radius, or the diameter. The formulas do the exact same thing. Typically, if they give the radius, I'd say use the formula for circumference that has the radius in it. If they give you the diameter, I'd suggest you use the formula that has the diameter in it. But you get to take that. So here, if we're finding the circumference of this circle, we can use, if they draw your diagram like this, with the whole line through it and this unit measure, that they're giving you the diameter here. This is an example where they're labeling the radius, all right? If they have the whole thing and the 12 inches is right here, that means they'd be telling us that's the radius, all right? But typically, the whole line with a unit of measure here, or a length, tells you that is the length from this point all the way across. Does that make sense to everyone? So if we're using the diameter, and since they give us a diameter here, that's what I'd suggest, we're going to use the formula. Oh, they don't do that. So they found the radius here. So the radius would be 12 divided by 2. So the radius is 6, 2 times 6. But that seems kind of crazy, right? When we could do 12d and we'd have 12 times pi inches would be the circumference, right? This is the diameter. We can use 2 times the radius, or we can use just the diameter, and then if we do, there's no work for this particular problem. You'll notice circumference, remember, the distance around, it's inches, not inches squared. If we're using the radius here, that's when I would suggest you use the 2 pi r. You can see 2 times pi times the radius, and so the exact circumference of this circle is 24 pi inches. If you want to put 24 pi in on your calculator, let's do that. 24 and then hit the pi button. It's the second button under your function, and then hit equals. Oh, I won't do that. You're going to do 12 times pi equals. So 12 times pi is 37.699, but actually we need to do 24 times pi. 24 times pi is 75.3982239, and that decimal goes on forever. So if we rounded to the hundredths place, 75.4, we'd be approximating the perimeter. 24 pi inches is the exact perimeter. Does that make sense, Joel? Does that make sense, Ilaria? All right. Finding the area, we always use the radius. If they give us the diameter, we have to know that the radius is half the diameter, and so we're going to plug in a times pi times the radius squared. And so the area of this circle is 36 pi square units. In this case, it's inches, so 36 pi inches squared. If we wanted to approximate the area, 36 times, if they don't tell you, you can use the pi button. If they do tell you, then use what they ask you to. But if you approximated this answer, it's 113.10 rounded to the nearest hundredths place, inches squared. All right, if they give us the radius, then we don't have to find the radius. Here we have to find the radius in order to use the area formula. So the area is equal to pi times the radius squared. Remember, that's the x squared button, so that's just 144. So the area equals 144 pi inches squared, and you do need to use this factor in front of the pi. We're not going to say pi 144 inches squared, right? We're going to say 144 pi. That's how many pies the area is, 144 times pi. Not pies you eat, Kason. What's your favorite pie, Kason? You don't eat any pie? Heavens to Murgatroyd Batman. All right, y'all caught up with me? All right. So we call these figures composite figures or an irregular shape. So if we're finding the area of an irregular shape, we are going to split this figure into a bunch of little ones. So we can make it a rectangle here, a rectangle here, a rectangle. There's all different kinds of ways you can split this. We could split it into 3 different figures that way. We want to split it into whatever way that we know the length and width for. We could split it into this big long rectangle into, well, this would be a square, this would be a rectangle. Just make sure whichever way you split it, you know the lengths of all the parts, right? Because you have to have the lengths of all the parts. Does that make sense to everyone? All right, so here we're going to write maybe. To find the area of regular shapes, break them into easier shapes. Then find those areas and add. You're writing that. Sydney, are you not taking it? To find the area of irregular shapes, break them into easier shapes, and find the areas and add. Kevin, do you want to check over it? We're good? Okay. Have a seat. You can finish these notes with us, and then watch the video to get the rest of the notes. We're going to be done here in a few minutes, so you may have time to get part of it done before. All right, so like I said, there's not one correct way to break them into easier shapes. This is the way we're going to do it. Now, you don't have to pull them all out like that, but this one, what they did was, our last thing we did here is they drew a line here, and you'll see this side of this rectangle is 9 centimeters. They've got this rectangle, and then this figure right here. How do they know this is 3 centimeters by 3 centimeters? Tyler?
Because the one side is, I thought you were talking.
So this one happens to be,
3 centimeters by 3 centimeters.
yeah, this one happens to be labeled that way, right? How do we know the height of this rectangle? Don't blurt out. How do we know the height of this rectangle? What do you think? Any idea? Any idea, Taylor? How can we find the height of this rectangle? So we know from here to here is 5 centimeters. Yes, this one right here. It happens to be half, but we can't just go, it looks like half, right? We have to be able to mathematically find it. How about, we know from here to here is 5, right? And from here to here is 2, so this would be the same length. So this and this would be the same length, right? So if the whole thing is 5 and this is 2, then we subtract the 2, and now we know that this is 3. Does that make sense? And you can just label it on here. You do not have to pull them all and redraw them all. I'm happy for you to draw the line through and mark it on here. And once again, my board is not working for some reason, so 5 minus 2 lets me know that from here to here is 3. This one's a little bit easier. When we draw that line, we see that this is 2 and this is 2, and once again, this one is already labeled the side measures. All right, any questions about that part? All right, so we are going to find the area of each of the parts. So the length times the width, that would be for this figure, right, figure 1. The side times the side, that's this little square here. And then the length times the width of this other figure here. Now this is not a unit of measure, this is just a label. Maybe A, B, and C would have been a better choice, but we find these are the formulas for the area for each of these figures. The area of this rectangle, the area of this square, the area of this. Can you do them separately, then add them together at the end? Yes, you can, right? So 4 times 2 gives you the area of this figure, 3 times 3 gives you the area of this one, and then 9 times 3 gives you the area of our third shape that we split it into. And so 8 plus 9 plus 27 would give us 44 centimeters squared. So one more time, if you do not label that unit of measure, you are not going to get full credit, and possibly not any credit, depending on how what the problem is. Tyler?
Why does it say side times side?
Because a square has only one length for its side measures, right? So typically we say that there'd be one variable to represent the lengths of all 4 sides, because they have the same. Okay? Typically that's how you know it's a square. One of the indicators that those side measures are the same length. Tajari? Tajari, sit up tall, buddy. Sit up tall. Taylor? Yeah, just a second. All right, any other questions before we get started on our homework? You can go ahead and scan and submit.